Hey guys, welcome back. So now we're going to be talking about our intro to the lab information. And a lot of this we talked about before, but I just wanted to make sure that we got everything together so that we could talk about it at one time. So I'm going to take you in to Alex. This is our Alex. You'll notice that I've changed one of the due dates for the density of a cube lab. I actually changed the opening date so that I could get into it so I could show you guys this in the student view. So this is my student view. This is what it looks like when there's something open at this point. And I can say, okay, I'm going to go into this. Now, remember that the density of the cube goes with that in that first lab, that matter and my brain is not functioning. Go me. Need the other one. So matter in units of measure, sorry. And it's the units of measure that most specifically deals with the density. So we've done all of our practice and our Alex homework that goes with that chapter. And now we're looking at, okay, here's the lab that I have to do. Now, there will be a lab lecture that goes with this, but I want to walk in and talk about some of the stuff that's here. Now, the other thing I want to mention to you is I said that there was stuff here about how to read glassware. So there is some information here about how to do that. And it talks some about the level of precision that's denoted by the glassware that you're using. So we'll talk about what that means and when you do the first couple of labs. So if you're looking at a graduated cylinder, the graduated cylinder is usually measured to 1 milliliter marks. But you can estimate beyond that. And so that's the precision that you have, is then like 1.5 or 1.7, because you're expected to estimate that one after that. So 1.5, 1.7, that's two significant digits. Okay. If you're talking about addition and subtraction, we're always talking about the 10th place. And if you're talking about multiplication and division, we're talking about two significant figures. If you don't know what that means, go back and look at the significant figure stuff again. Or do that if you haven't done it yet. Okay? So every piece of instrumentation or glassware equipment that you're looking at should be read one past the measurement that is present. Okay? And that will determine what you're looking at. Okay, so you have to estimate that last place value. Now, accuracy is different than precision. So precision is how precise that number is known. Okay, so how much significance, how many digits we can get out of that. Accuracy, on the other hand, is if this thing is supposed to be 1 milliliter, does it actually measure a milliliter? And not everything is that good. Okay, so some things are measured well, some things are not. Okay, that's something that we need to be able to talk about when we talk about that, is how accurate that thing is. Now, part of your accuracy is going to be determined by the demarcations that are on that glassware. So if you're looking at a volumetric flask and it only has one mark on it for 40 milliliters, you're only going to measure 40 accurately. Nothing else will be accurate. Okay, you can guesstimate, but that the only thing that is calibrated for is that 40 mils. Okay, if we're looking at an Erlenmeyer flask, you can usually guesstimate some bits in between. So there are usually some markations that are on them, and you can use that if it's marked to have a 25 mils out of 150, then you can get a decent measure on that line based on the line that's on the flask. Okay, burettes are really, really precise, so it's very easy to get a very good measurement on those. They actually are marked to the hundredths place, so 2 decimal places, and then you can estimate one beyond that. So that's usually the most precise piece of equipment that you'll see. Graduated cylinders, again, you're measuring to the 10 and then one beyond that kind of deal. So 10.1, 10.2. Beakers are not, I mean, it depends on the beaker. So some beakers are demarcated fairly well, some are not. and it depends on what type of equipment you're using. So the more demarcations there are on a piece of glassware, the more expensive it is, because it then assumes that you have higher levels of accuracy that can be attained with that. And in order to make sure that that accuracy is present, they have to do a lot of testing on it after they've built this really precise piece of equipment. Okay, so they have to test it with several people several times to make sure that it actually gives the accuracy that you're looking for. So that increases the price. Okay, so that's one of those things that happens there. So there's some information about those. There is some talk about mass and volume determination and how these things are done in the laboratory. So mass is not the same thing as weight. You'll hear me talk about this. It's not the same, and that's important to us who are pedantic about these things, because there is a difference in those definitions. Sorry, a type 1 diabetic. I have to make sure that I'm keeping track of things. I apologize. So that, just discussions about what these methods are, how they're done, all of this stuff is present here. So that can be useful to you before you go in and start the laboratory. Now, when you go in, you can click the lab, and it says, "Ooh, hey, you're going to do this lab. It's one of unlimited attempts. This is when it's due. You'll get the best score. If you turn in late, it's 50%. And your final submission date is August 6th. Okay, so that's the last day that you can turn it. If you look back here, you'll see that it has a due date and not that last due date, that, the last day that you can turn it in. All right, so that's what you're looking at there. And we can start this. And what you'll see as you go through this, there are some key concepts that'll tell you what you should be looking at and some things that you may need to know. So 1 cubic centimeter is 1 milliliter. There's some overview of what you're going to be doing in the lab. They'll talk to you about the scoring for that particular lab. And then there's some stuff about before you begin. Accurate volume measurements are taken at the bottom of the meniscus with your eye level parallel to the meniscus. Now, you should already know this based on the labs that we've done before this, but you need to make sure that you're using that glassware appropriately so that you're getting the right value on that. Okay, so it's always the bottom of the meniscus, so this lowest part right here, and that's where we take. And this is not the best glassware, the way that they do this. Usually what happens is you have a line that goes halfway around that particular piece of equipment. And so when you hold it up, you should not see both lines, because if they're exactly even, you'll only see the one in the front. So you shouldn't have it so that you can see both. All right. And that's how you know that it's flat. And you need to get that to be flat wherever you can. I mean, really what we would prefer is that you're doing it on a hard surface so that you're not moving it while you do it. But that can be really complicated. For tall guys, that's really hard to do on the lab benches. For us short girls, it can be really tough to do on the upper parts of the benches that are there. And yet the bench is actually about half my height, so it becomes complicated. But that is the expectation. And then it talks about when an object is placed on liquid, the object will float if its density is less than the density of the liquid. The object will sink if the density is greater than the density of the liquid. When the object has the same density as the liquid, it will be suspended. Okay. And then there's some information about the density of these materials. Okay. Now you should be able to access this part later, but the other parts you may not be able to. Okay. So it's important that you write some of these things down. Now, when you write those things down, bear with me just a second. I don't really care where you write them down. It doesn't matter to me. But I have a lab notebook. This is a chemistry lab notebook, and it has places where I can write all of these things down. And when I'm going into the lab to record data for you guys, I will be using this, and I will show you how I use it. But this is where I would record all of my information. And the reason that I do that is because this notebook, like any notebook that you should use, is hard paged. So it has a book line and then a dash 5 page and then 6 page, so that you know what page it is. And the reason that it's hard paged like that is because if you rip one of these out, you may not know it's gone. So that page number will tell you if one has been removed from this, which is never supposed to happen. Okay, it should never occur. You'll also see when I use this that there is a signature line where I sign and a date. If I were actually doing this in the lab, someone else would have to witness this. Okay, so if you were in a physical lab, I would sign off and date that as well. And that's to indicate, okay, it has been witnessed that this piece of paper has the following information on it. And so you can be asked in a court of law, if you're a witness on somebody's documents, you see all of this information on this date at this time. And so what we need to make sure is that when we fill out these documents, if there's any extra space, that has to be X'd out. So we draw a big X through it, and then we initial and date it. And the reason that we do that is because we have to indicate, we have to make sure that we can't go back and add something else later. Okay? Now, these observations are a legal document, and they can be held, you know, if you're working in a laboratory, if you're working in a hospital, if you're working someplace like that, that is something that can come up in a lawsuit. And unfortunately for you, it's usually not you that has to talk about what's in it. So one of the lawsuits that I was involved with, my boss's boss is the one who had to speak to what was in my lab notebook. And it wasn't just my lab notebook. There were a bunch of them because we did some work showing that a competitor's material was actually the same as a trademark material. And so we had tests that showed that evidence. And so our lab notebooks, the testing that we did, the results that we saw, that was all part of that lawsuit. Okay, so that's one of those things. And the reason I mention that is because it should be legible. And I know that's really hard. For me, that is nearly impossible. But that's just the other thing. Now, all of this gets said in the notebook format document. If you're not going to take 111, you probably won't have to keep a notebook. You're not required to do so. It's just a good habit. It's a very good habit. And if you start the habit at the beginning, it's easier to learn than unlearning bad habits that you've picked up along the way. So 111 requires a notebook, 211, 212 both require a notebook. And the expectation is that you already know how to keep them. Okay. I think it's a little sad that we're not requiring them in the 110 labs anymore, even for the online students, because 111 online, you are expected to keep that lab notebook. So just so you're aware. But anyway, I would write all that stuff in my lab notebook so that I had it available if I needed it when I was going through this. Okay? So knowing how these things are, I can leave myself some space to say, okay, here's information that I got when I was going through the objectives and the scoring and all the rest of it. We then go into this, and it says, if the balance was not tiered to display 0.0 grams prior to adding the cube, which of the following statements are true? Select all that apply. And this is one of those questions that I would record, and then record what I answered. Okay, so the mass of the cube can be calculated. The mass displayed on the balance before the cube was added will need to be subtracted from the mass displayed on the balance with the cube. That is true. That can be done. No calculation is needed to determine the mass of the cube. That is not true, because if it wasn't a 0, then we have to deal with the number that was there to begin with. The mass displayed by the balance is the mass of the cube. Nope, not true, for the exact same reason that I just talked about. And the cube can be reweighed after the balance has been tiered. Yes, absolutely it can. So both of those two should be true, and the two in the center should not be. So then I say, okay, go to phase 2, and it says, yay, you answered them right. So now I know that the two things that I said were actually correct. If I got one of them wrong, it would ask me to rethink that. Okay? So for instance, if I were to come back here and change this, oh, it's not going to let me change it now. Sorry. But if I got it wrong, I'd say, are you sure about that? Maybe you need to rethink that kind of thing. And that's okay. Place cube on balance. So I'm going to tear this because I don't like to have to deal with that. And I place the cube on there and I say, oh, it's 0.91 grams. And so I would record that in my lab notebook, 0.91 grams. And so if I look at my lab data, it says 0.91. And of course, it's listed as grams, so I don't need to include that there. I'm really pedantic. I always include units with my numbers, so I don't ever do this kind of thing here unless it's a table. I wouldn't consider this a table. I would consider columns to be a table. But anyway, so then it says, all right, determine the mass of the cube, record the mass in the lab data. I did that. So now I go to the next part. It says use the caliper to pick up the cube. So I pick up my caliper, I pick up a cube, I measure the edge of the cube and record length in the data, and it's 1.000. So I say, okay, 1.000, and I write down all of the decimals that were present there. Now I have people say, well, why do I have to include them if they're zeros? Because I need to know how precise that number was. Because if I only wrote the 1, then I only have 1 significant digits that I can work with when I do these calculations. Here, I have 4. So that's important. Okay. So then it says, use the cube's length to calculate the volume, recorded in lab data. So since I need to cube that 1 times 1 times 1 is still 1. So it's 1.000. And the cube density is the grams divided by the 1.000. So I have 0.91 grams per centimeter cubed. And it's 2 sig figs because I only have 2 here, I have 4 there. So that should be the answer that they're looking for. Mass and volume to calculate the density, recorded in the lab notebook, and yay, we're good. Awesome. That's totally cool. Now, do you need a lab notebook? No, because you actually get asked to fill all of this out. I have students who take screenshots of this and then use that when they're taking their quizzes. That's perfectly fine. It's absolutely fine. The only thing I'm going to tell you is that you have numbers here, but it doesn't show how you calculated them. And so that can be problematic unless you make some recording of how you did that calculation. Because you may not remember when you go to take that quiz. How did you get that number? So that's one thing that I would talk about there. And complete the following steps for each liquid listed. Use a clean pipette to transfer 3 to 5 milliliters of liquid to the graduated cylinder. So here's my grad cylinder. Here's a clean pipette. And I put it in the methanol, which is this first one here. And I put that in there. And then I say, okay, I haven't added enough yet. I add more. You get roughly 1 milliliter when you do this. And I put that in there and I say, oh, okay. So this is 3.00. That's how I would report that. So I can go to my lab data. Oh, sorry. I don't want to do that. I actually don't need to know that part yet. So now I need to take and put a cube in there. And I zoom in again. And I see, oh, well, it's sunk. Okay, so in my lab data, I would say that it sinks. Woohoo! Now I can minimize this. I can dispose of that. Then put the graduated cylinder in there. And then I'm going to pick up another thing. Pick up my ethylene glycol. 1, 2, 3. Put that in there. I can zoom in. Okay, 3. Awesome. Put the cube in there. And oh, look at that. So it floats. So I'm going to record that. Now I can dispose of this. Sorry. Yeah, I tried to put it in the wrong place. So I need to dispose of that and then put it in there. That's helpful. And then I do the last one, which is the water. 1, 2, 3, and I put that in the waste, and I put my cube in it, and I can see that it floats as well. And now I've done everything I need to do for this. I need to dispose of the chemical and then put that in there. So this is fairly typical in the laboratory. We would have things very well labeled. You'll notice that there are safety diamonds on these. I'll tell you how dangerous things are. I can't off the top of my head remember what all 4 of them are, but I know that I can, there's a reference in the laboratory that I can look at. Actually, I wonder if there's one of those notebooks, because sometimes they have. Just curious now. Safety. Periodic table, the metric conversion units. Nope, not one in here. Okay, so sorry, but there is one in the lab that I could look at if I needed to. One of them is flammability. One is how dangerous it is to people. Actually can't even remember the other one at the moment. So the one down at the bottom is a specialty one. And we don't list that for water because we assume that water is perfectly fine everywhere, which it technically is. So there's that. So now I can go to the next phase. Okay, awesome. The polypropylene cubes have a density of 0.946 grams per milliliter. Identify the true statement. Select all to apply. The cube sinks in methanol because methanol's density is greater than the cube's density. Well, okay, remember at the beginning, and it said that if it was the same density, then it would be suspended. If the cube had a lighter density, then it would float, and it sinks because it is more dense than methanol. Okay, so this is not appropriate. Cube floats on ethylene glycol because the cube's density is greater than ethylene glycol. That's not true either. Cube floats on water because the water's density is greater than the cube's density. That's true. And the cube sinks in methanol because methanol's density is less than the cube's density. That is true as well. Which liquids, and actually I'm going to choose one of those wrong so we can see what it looks like when we do that. Which liquid could be used for displacement? Well, for displacement, I need it to sink. So methanol would be the best choice for that. So, all right, let's see what we do. Question 1 is partially correct. And it gives you an indication of where you've gone wrong. Recall the properties related to density. When will an object float or sink in a liquid? Refer to the simulations in production for additional help. And you can't get back to it from here. So hence why I said you might want to record that. And question 2, it says, oh, correct. So it says, please try again. So I knew that B was wrong, but I did it so I could show you what it would do. So now I say, okay, C and D. And it goes, yep, okay, we're good. Awesome. So use our clean pipette to transfer 3 to 5 milliliters of methanol to the graduated cylinder. 1, 2, 3. That goes in there. Place cube in the graduated cylinder. Or 3 there. 3.00. I then move the cube into it and I look at it again and I say, okay, we're now 4.00. And again, since I can read that it's exactly 4, that's 4.0. And then 1 beyond that is the 0 from there. Okay, so that's why I have as many decimal places as I do. Calculate the cube's volume. In milliliters is 1.00. So the difference between those two is that volume. And then the cube density in grams per milliliter. So I have grams as 0.91. I divide that by the 1.0. So that's 0.91. And it's only 2 significant digits because there are 2 here and 3 there. So it's only 2. Okay. So that's what we're looking at there. And I have recorded that. It didn't tell me to take stuff out. So hooray! Review your observations of the behavior of the cube in each liquid. Which liquids can you use to make your suspension mixture? Well, I need to pick something where it floats and where it doesn't. Okay. So I would say this one. I would also say that one. So if I take the two where it was suspended, that's not going to help me. Or the two where it floats, that's not going to help me. I need something that's more dense and something that's less dense. So that's why I chose the two that I chose. Say, oh yay, arasa. Okay. Now and this is highly repetitive. Use a clean pipette to transfer methanol to clean graduated cylinder. Okay. And it says 2 milliliters of ethanol. So 2 mils there. Put that in there. And I get another one and 1 milliliter of the ethylene glycol. Okay. All right. Then use clean glass stir rod to mix them together. So I need to pick up one. Oh, they put them over here. Put that in there and stir it. And that mixes it all together. Hooray! Place the cube in the graduated cylinder. And it sinks. Okay, so I'm going to look in my data. And I'm going to say, all right, so volume of methanol here was 2.00. This one was 1.00. And the cube's behavior is that it sinks. Okay, awesome. Now, I'm going to leave this here. I'm going to move it down. And I'm going to come out of here. And I'm going to dump that. I'm going to put that over there. And it says, okay, now do the next one. So 2 milliliters of methanol. Put that over there. And I can see that it's exactly 2. It wouldn't be exactly 2 because these things are not that accurate. So just so you know, it's not quite that easy in the laboratory. It's approximately a mil, but not actually. And then 2 milliliters of ethylene glycol. So 1, 2, put that over there, check it again. And we're at 2 there as well. So I can come here and I could say 2.00 and 2.00. And the cube's behavior, well, I don't know. I haven't moved it yet. Oh, that's right. I have to stir it. See, that's what happens when you mess up. It tells you to do something else. Put that in there. Now I put the cube in there. And look at that. It's suspended. That's at least different. So it's suspended. Okay, that's awesome. Now I have a bunch of other things that I need to do. So I'm going to dump this in here, and start all over again. 2 milliliters of methanol. I can verify that is exactly 2. 4 milliliters of the ethylene glycol. 1, 2, 3, 4. Oh, sorry, I read the wrong one. So yes, that was only supposed to be 3, and it stopped me from doing the other one. Go awesome. 3.00. I need to stir this. And then I can put this in here. And look, it floats. We all float down here. Sorry, I'm a big, huge Stephen King fan. It's an It reference. I apologize. So that's that one. Now I can get rid of this, put that in there, and there you go. So I'm going to do all of these just because I want to walk through the rest of this lab, and this will be the walkthrough of Virtual Lab 5. Okay. They are pretty much this boring. Milliliters of methanol, and I'm not going to check it because it's always been accurate every other time. So 1, 2, 3, 4, stir, and it floats. Of course, usually me, if I know it's going to be that accurate, it won't let me. Okay, fine. So I take this, I dispose of that, I get rid of that, and then All right, we're going to do it again. And we're still doing 2. Do, get rid of that. And now we're doing 5. 1, 2, 3, 4, 5. Stir. Dump. Oh, look, it still floats. If it were me, given what I'm supposed to do, based on this, I would have filled out the entire table to begin with. And I typically start with that kind of thing anyway. And then if I need to make an adjustment to it, I'll just cross out the part that's wrong, initial and date it, and put in the correct value. Okay. But I am really neurotic. If it tells me to put in 2 mils, I put in exactly 2 mils. So that's just me. If you do exactly what it says and you still don't get the right results, it wasn't your fault. And thank God for that, because that it wasn't my fault, because otherwise I wouldn't have passed organic. 4, 5, 6. Stir. And it still floats. Okay. Awesome. So now we go there. We get rid of that. Use your observations to identify mixture to calculate the cube's density and record in lab data. Well, the one where it's suspended is the one that I want to use. So I'm going to be using mixture 2. If you take a while, it asks you. It's annoying. It apparently doesn't know that you're still doing stuff. Calculate the cube's density and record that in the lab data. Well, okay. How am I supposed to do that? It's a really good question. How to calculate density of liquid mixture. And it has a little video that walks you through exactly what you're supposed to do. Okay, so this requires both densities be known. And this is where I come in and say, oh, okay, methanol density, ethanol density.
Calculate the density of any solution by using the densities and volumes of the liquids that comprise the solution. Determine the mass of each liquid used by multiplying the volume used by its density.
Okay, so I need those volumes as well. All right, so now I'm going to move this over here. And I know that methanol density, I don't know. Volume, milliliters. I'm only doing this in Excel because it's easy and I can show it to you. So the volume that we used for that one, that was 2 milliliters of the methanol. And 2, I think was 2 here as well, but we'll verify that with our lab data in just a minute. We can't do that while we're in this part. And actually, I'm going to change that. And the reason I'm going to change it is because I want to know how accurate that was. My head gets very wrapped around how many digits I have. Okay, so I can multiply those together. That's what they've said that I need to do. So it's going to say 0 now, but when I put that value in there, then I will get an answer. Okay, awesome. So that's my setup so far.
Of the liquids together to get the mass of the solution. Divide the mass of the solution by the total volume of 5 milliliters to get the solution's density.
So we need to add those numbers. That's what it says, is add the numbers. So that will be my addition. And then I will have a density, and that's going to be equal to, and the volume that I have is equal to volume here plus the volume there. Density equals that mass divided by that volume. And again, I have a 0 right now because I don't have any values. Okay.
Of 0.873 grams per milliliter.
So, okay, I watched my little video. I close this out. And I say, all right, density of liquids. Ooh, and this is that same table that they gave me before. So if I'd written it down, I wouldn't need to reference this again. I could have done this whole calculation without having to do that. Now, the density of methanol is 0.7918. The density of the ethylene, oh, it's actually ethylene glycol, sorry. And the density of the ethylene glycol is 1.115. So that gives me 1.5836 mils here. Okay, I end up with a, mass there, 2.23 grams here. Okay, and actually this should only be, well, no, three decimal places. Oh, 3 sig figs. So I want to go there. This one is 3 also, so that one's okay. And this one is going to end up being 3 as well. So that's the number that I need to report, is 0.953. And yay, I have done everything. Now, if the balance was not tared, what do we do? Okay, here are all the questions that they asked me, so I can print this entire thing. And this tells me everything that we did on this particular lab, but it does not show you that calculation. Okay, so you may get to the quiz and say, oh, great, well, I know how I calculated it. I don't remember how I calculated it. So that's why it's important that you record these things so you know how it was calculated. Then when you print this out, you can write that on here and you'll have everything you need to do that post lab. Okay, so there's that right there. You are now completely done, and that's it. Now, like I said, this is going to be our recorded lecture for this particular experiment. So Virtual Lab 5. That I believe that I showed you the lab data, the things that I think you need to be recording. So all of that is going to apply every time. And, I think that's everything that you need from there. So I hope that's all lab information that you need. Remember that when you go to that post lab, which I am not going to do, when you go to that post lab and you won't see it, it's not open yet. So if I do view all post lab density, this quiz is the density quiz. Okay. And there's only a couple of questions that are on here, but you need to make sure that you do that the way that you're supposed to. Okay. So I think that's everything you need to know about the labs. And if you have any questions, please let me know. And I'm sure that took way more time than you were hoping that it would, but that's what we've got. Thanks, guys. I'll talk to you later.